Yeah, don't worry. That part is gonna go.
All right, cool. All right, so this is the second open talks. Just to give an introduction about who we are. Pretty much we're just a bunch of international and interdisciplinary group of people interested in a bunch of strange things completely outside our general knowledge base. We've invited Eric Gerard Rothstein along. He has studied bachelor's in systems and computer engineering in the University of Los Andes, Colombia, and also completed a master's in engineering in area systems and computing in the same university. He has gone on to be in the publication with enforcing security properties by solving behavioral equations, engineering secure software and systems. Welcome, Eric.
Thank you very much.
Yeah, nice to have you along.
Yeah, I'm glad to be here.
Yeah, great.
Hopefully I can talk to you about interesting things and solve a couple of questions and teach you some stuff.
Release the confusion about some very technical information. It would be it's exciting for us. So
Sure.
yeah, exactly. So maybe just introduce yourself and what you're working on at the moment, and let's start there.
Okay, excellent. So, my main background was in systems engineering, and I started to deviate a bit towards the mathematical side, so a bit more towards computer science. And I started to develop an interest in security, which is what I am currently doing. And as you have heard, this Bitcoin, the blockchain technology itself, offers very interesting properties, both for usability and for security. So I also got interested in that. I am now not exactly doing blockchain, but I have worked with it before. I am right now working in the security of cyber-physical systems, so trying to protect systems that have, let's say, this computer controlling it and this physical part that interacts with the world, so let's say a production plant or a car itself. Yes, but this is more or less what I am doing.
Oh, cool, great, yeah. And so yeah, if you could go into a little bit of detail into what the exciting things you're working on at the moment in this field, or yes, what you some of the detail of what you're working on.
Okay, so I am currently working in trying to find an approach to attest the design of cyber-physical systems. And what do I mean by that? So building these systems, it's very expensive, and you want to be as sure that you're not making mistakes as early as possible. So at the design phase, if you're able to evaluate your proposal, say, okay, this is the proposal for the system, can you tell me is this secure or not? And if you have these tools, you save, let's say, the production costs that you would incur in making the product a reality and then realizing, oh, we screwed up here, we could have done this better. So this is this design guided approach that we take here also at this university, the Singapore University of Technology and Design. And yes, it's trying to apply very well-known methods in computer science to try to attest the properties of these systems with respect to security, like model checking or doing some satisfiability modular theories, solving, this mathematical and logical stuff.
Yeah, it's actually quite interesting because I was reading the beginning of your book, and it talked about the two ways of looking at system security, and it was like through system specifications and system requirements. And then my personal background is in design, and I was able to recontextualize that into security requirements were like, okay, why are we doing it? And then system specifications was the design result of why you did it. And then the book talked about the rationale of kind of how you can develop a security system based on this through deductive logic. And I think, okay, this is really where the design perspective and maybe the computer science perspective changes, because in design we really go outside of the deductive framework, and I was just wondering, like, and then in the book you were saying it's difficult because you have this interplay of open questions. So like the deductive logic is complicated because the questions that are always coming out of this are open and not so linear.
Yes.
And were you involved in this part of the construction of the security systems as well in this book?
I am not entirely sure what the publication that you're talking about, this enforcing security properties, or
yeah, enforcing security properties. Yeah.
Yes. So let me go back a bit to that. The idea there is that you want your system to behave in a particular way, and to try to put this into words, it is sometimes quite complicated. So the idea of using these logics or to use these tools is to actually be able to put what you had in mind into the computer so that it understands what you want and it performs accordingly. And the problem that you sometimes find is that you do not find these channels to like present the computer, okay, this is the idea that I wanted to give to you. So you end up chopping the idea in parts and trying to fit some sort of language that you have. And it's an approximation, but it's not exactly what you want.
Okay.
So the idea, or what I believe it's important, is to have this language that allows you to truly express exactly what you need at the right level of abstraction. And this is where I believe that several disciplines could come together. If you, from the perspective of, let's say, product design, want to express some particular property or some particular idea, then it would be very nice to have some sort of good framework where you can exactly say what you want. And I guess you already have some of those things. You have, I can imagine some computer models that you can put into a printer. The printer understands what you mean. So this type of things, but maybe also to the level of human to human, and you can describe things in a particular formalism with these drawings and things like that. And for the case of this security, sometimes we do not know what security means, and we want to have this language to describe what this property really is. And it can go beyond just some mathematical properties. It can go to the level of that involves the nature of the product, so that the car doesn't crash or things like that. Mm-hmm. You have to really work on this right language.
Okay, right.
But, yeah.
Okay, so it's a bit about developing the language for which then you can then apply to the system.
Mm-hmm. Yes.
And how do you see that with your interest in blockchain before this development in kind of system security, or was blockchain something that came out of your interest in this field?
So, okay, in the environment where I work, you see a lot of booms. So there was this boom on the internet a long time ago, and then, I'm going to jump ahead and have this boom on blockchain. Is where do this boom of blockchains come from? Because afterwards you will have Internet of Things, cloud computing, etc. But we're not going to talk about that. Think about the following: the banking system that we currently have requires banks and these credit card companies to act as trusted third parties. If you want to make a transaction, they register that and they move funds from one account to another, and you have to trust it. There is like no other way around. If they wanted to go corrupt, you could lose money because they will just make transactions for you. It will be sort of hard to like counter the argument because they control the system. You have to, I mean, you're at the mercy of them. We have to trust them, otherwise we cannot use the system. Bitcoin came out as an alternative that removes the trust from this third party and distributes, or sort of distributes the labor of having to register the transactions to everyone in the system. So the really nice thing about Bitcoin is that it not only involves, let's say, mathematics and computer science for the technology that it requires, but it also involves economics, and it's a pretty important component because without economics, some things in Bitcoin might not work. But yeah, this proposal on Bitcoin, which was published in 2009 by Satoshi Nakamoto, which is an anonymous author, no one knows who he is, had a pretty clever solution that makes these components that I was saying, economics, computer science, and mathematics, to provide the what is currently known today as Bitcoin, which then generalized to the blockchain technology that you can use in different other scenarios.
Okay, right, yeah. So this is an interesting, what interests me is like this idea of the change of trust from the bank running the system to the user. And in it, it's the user who registers the transaction.
Yes.
In a way, when I think about this from like a more naive understanding of how computer programs work, I feel like if I am the one responsible for the registering of the transaction, actually I am putting my trust into a program that was neither written by the banks nor by me. And then how do I know that this program is a safe or is doing what I wanted to do? I'm putting it onto the public ledger.
Okay, so let's put trust at two different levels. So you have the trust that you would put in your banks, and you would have the trust on the banking system itself. And the same thing you can have with Bitcoin. So you have the trust that you could put on the peers in the network, and the trust on the system Bitcoin itself. If you don't trust, let's say, the Bitcoin system, you won't use it. I mean, why should you use it? But then, this is where I say economics plays an important role here. If there is a currency that no one uses, it is worth nothing. Yes.
Yeah.
So it is in the interest of everyone in the network to keep things working, and this creates a reputation for the system, and this reputation you could trust. Mm-hmm. So if you see that the system is historically stable, then there is a pretty good chance that you can put your money in there and sort of be safe. There is no real guarantee. You have to trust, in that sense, the system as a whole, but you don't trust the individual people that are in there, because there are mathematical tools to work around trust in this case.
Okay. And because the ledgers are public from the beginning, every transaction is in a way transparent. But this raises another question for me, because if everything is transparent, a lot of the debate around Bitcoin or blockchain, well, Bitcoin especially, is, well, from my understanding, is that it's also completely anonymous, and this creates a lot of, it almost seems paradoxical in a way that everything is available to be seen in a public ledger, but then nothing is being able to be deduced from it in terms of who is or why these transactions are happening. Is that correct, or is that a wrong interpretation?
You are right. So the thing is that it has to do with what represents you in the Bitcoin network. So when you go to the bank, you have to give all your data, your name, your social security number, or whatever you need to give. And I mean, it's really easy to track you. Your bank account number is tied to you. But for Bitcoin, what you need, it's a pair of cryptographic keys, which are actually, let's say, pretty big numbers that have very nice properties. And what you use is that you present the public version of the number, and that's your identifier. And you can do this over the Tor network or whatever tool you can use to create anonymity. So it's like, this is the number that I want to be identified with. And that is your identity in the Bitcoin network. That's it. So everything that is tied to that number, you can trace in the ledger. That is true. And that's how you get money, and that's how you spend money. But to try to bind this number to your identity, to your person itself, might be hard. So this is where the anonymity part comes from. It is not impossible, though, and it could happen that, let's say, if you're a criminal and you're getting bitcoins or criminal activities, when you try to spend the money, people know that the money that went to this account might have come from criminal activities, and they will track the number. And if you say deliver a packet to, I don't know, some address, they might catch you there. So it's not that it's untraceable, but yeah, there is this thing. The other thing that happens is that you could have several of these numbers in the Bitcoin network. So you could have two pairs of private and public keys, and you can use them for different transactions. And in theory, people would not know if these two keys bind to the same person unless they have access to additional information.
Mm-hmm. It's quite interesting. If you hear a lot about people being able to, in terms of like from the telecommunications networks, just based on people's behavior in terms of how they use their telephone, you can determine a lot of things based on about frequency, maybe the amount of time they spend on their telephone. A lot of these like factors can tell you a lot of personal information. And I'm researching a bit about bacteria at the moment, and there's a whole lot about science coming into like all this personal history that can be taken out of a saliva swab of your bacteria. So
nice.
It's very interesting that like this bitcoins can stay anonymous completely, but your behavioral patterns, if you're using the same identity, would start to become known. And I was just wondering, what is your opinion on this? Or is it something that you have thought about?
So it depends on what you want to do, on which side of the story you're on, because I mean this type of properties, anonymity, transparency, let's say the inability to deny that you did something. This is what we call non-repudiation. Can be seen as a good thing or as a bad thing. So I like to think about this as we do with guns, and it's a very controversial subject, so I won't go in there. But you can use guns to defend or to attack people. And we have seen the use of crypto itself to protect our data. Say we cipher our communication, we make it hard for attackers to know what we are saying. But attackers have also used crypto to now encrypt the documents in your system, which is this ransomware that you hear so often now in the news. So this is using crypto against the users, and you could expand the application of all these different properties. So you can use anonymity as a good thing to protect these whistleblowers and I don't know, witnesses in a very important trial or something like that, whose life might be threatened. But you can also use in, let's say, the dark web, try to remain anonymous to commit felonies or things like that. So there is sort of a which side are you on here? I like to think that we are creating tools to make the average person feel safer and not making tools that can be misused ultimately. But bad guys sometimes just find a way.
Yeah.
So concerning, let's say, this traceability, it can be good because, I mean, you can catch criminals this way, but if a criminal does the same on you, then they might be able to trace you, to find you, and maybe blackmail you or whatever. So you see, there is this kind of balance that you have to sort of take into consideration. But I mean, ultimately, it's about who the majority are. And if the majority is the good ones, I believe the scenario in the end is optimistic.
I like this. This is a nice way to look at it. I like that. So maybe this is a nice way to move into other fields outside of Bitcoin. So yeah, where are some good areas this technology can be used? I was looking at online, and the top two that that someone recommended was the housing market and hospital records. And I was just wondering, okay, but what is your opinion on where the technology can go outside of Bitcoins?
Okay, so just to put things a bit into context, this system has total transparency and it's very hard to corrupt. And this is like the two main properties. So you would want to use this type of systems in places where there is a huge need for traceability. So I was watching an IBM video that was very nice, and they were explaining how you could justify that a diamond you buy is actually, let's say, an ethically produced diamond. So and you can use this blockchain technology to say, okay, this mine certifies that the diamond came from here, and then it was given to this transportation company, and then they moved it. There was this jeweler that created the diamond, it designed it, and then it was sent to this parlor where they sold it, and that's what you're getting. And you can track back this thing, and it's really hard to forge this let's say, this history of the diamond because of the technology. So in scenarios where you need to sort of find or trace the history of things, it's very good. I would say that the usability shines for smaller systems. So one of the reasons you don't see Bitcoin nowadays implemented in every bank is that it has its flaws in terms of efficiency. So if I understand correctly, in average you can verify like 1 Bitcoin transaction per second, while the traditional banking system can verify thousands or something like that.
Okay.
So there is that. And if the system is too slow, it is unusable. So if you have to wait too much, people will just not be able to work with it. So maybe, of course, it depends on your scenario. There are other factors. For example, politics. I have heard some discussions of whether you want to use this blockchain for electronic voting or things like that. And one of the things on this blockchain technology is that it's really hard for the attackers to like corrupt the system, but it's still possible. So if you have a very, very corrupt government, let's say, and they control the majority of these things, they can still ruin things, let's say. So I think this application, the application of this technology works pretty well on the scenarios that you were mentioning. Let's say you want to keep a record of let's say, of your history of disease, what medication was given to you, what kind of operations have you had, because that gives the doctor a nice view of your system, of your history, sorry.
And your system.
Yes, as well. But then you come into a different problem, and it's like, okay, if this thing is so public, how can I prevent, let's say, for people that suffer from a let's say HIV or AIDS, which is sometimes still frowned upon in some countries. If they find out that you have HIV, they could fire you, and this is how you protect the privacy of this person. So how do you provide these very nice, let's say, properties of the blockchain technology for this business, and how do you protect also the privacy of the people?
And this issue of privacy is just because potentially the encryption can be unencrypted in some way. Is this the corruption in terms of like the losing the security is more based on the fact that the information becomes online and can be transferred from one hospital to another, or that someone can kind of interrupt this this transfer of digital information and unencrypt the information as it is going through? Maybe it is both, or maybe I don't understand the system enough.
No, it's okay. Of course, it depends on the implementation, and all these attacks that you were mentioning are possible. But I was thinking also on the case where you actually want to give permission to someone to read your files. Let's say you want to tell your doctor, look, with this key you can decrypt these files. So you are placing some sort of trust in your doctor that he or she won't share this key afterwards. Because if you wanted to use a one-time key, then you would have to somehow alter the whole data, let's say re-encrypted or something, for the next use. And this puts a lot of impact on the ledger because it is distributed, and it's not only you who is going to be doing this thing at the same time. So there are these challenges that come from these specific use cases, application use cases, depending on what you're using the system for. So at its basic, what I like about the currency system is that, well, it's the original, so we understand it better. And there is the component in economics that also helps balance the trust in the system. I don't know if the same applies to these other applications. Could be, but I am not entirely sure.
Okay, that's interesting, yeah. So just trying to contextualize what the information I've kind of received is that half the reason why a good chunk of why things are working in Bitcoins is because the system is supporting itself or wants it to succeed. And when you introduce it into another field, how much of a factor is, or where this kind of support for the system comes from, is still maybe a bit of an unknown or something to be developed.
Yes,
in terms of making it a workable system. So
there are several misconceptions, and we sometimes face this when we work in information technologies, is that when you hear a hot topic or keyword like cloud or blockchain, you think, okay, or a good salesman will tell you this will solve all your problems. It is not. So there are things that have to be done. It might be a good start for an application that does solve your problems, but it's not like out-of-the-box solutions. Those are really hard to come by. So if, let's say, you don't care about privacy, fine, you can use blockchain in your hospital and medical application. But how realistic is that? You see? And yes, I guess it's very application dependent. So you really need to study whether it makes sense. Economic-wise, it has shown that it could work for, let's say, small communities. So let's say that your country is in crisis and you cannot print money and you have to come up with some solution at a short period of time. Maybe you can use this, and then afterwards the government intervenes and say, okay, we're going to do some conversion, so you give us the bitcoins and we give you real money now that the crisis has been averted. This could work, and I can see this realistic. But I mean, only time will tell if this type of technologies can really be applied in all the different scenarios. There are a lot of people still working on this.
Yeah.
So I guess we will wait.
Yeah,
and see what
So maybe
happens.
this is a good time to talk about so if you this is always the thing with something so complex as a technology like Bitcoin, but it's always interesting to think about where it could go. How do you enter into it? Like what do you think is a good way for someone who is maybe it's a bit more easy for someone from your discipline in computer science, but if you are coming at it from more of a broad perspective, are there communities where it's where there are good places to jump in to understand this technology, or ways to kind of use it to understand how it is working in a way?
Okay, so depends on the level of involvement that you want to have, of course. If you can find a lot of good online resources. I have seen a couple of courses or small courses on explaining what the Bitcoin is in the internet from different universities. So I don't know if I'm allowed to sort of do advertising here. Am I?
Yeah, of course. Yeah.
I don't know. Yeah, but let's
Don't
say you can find things in Coursera or in, let's say, OpenCourseWare from MIT. You can find this type of things,
Alright, cool.
and that I would say gives you like a good level of understanding, and you can also study at your own pace. If you really want to get more involved to this level too, that you could buy a bit of Bitcoins, not too many, sort of like you get the details on the technical level. And if you want to get a third level of understanding, you could also develop your Bitcoin client. So you program it and all that stuff. And now you're faced with all these different challenges of things. This is really not recommended for security reasons and things like that. But I think it's a good didactic exercise.
Yeah. And is it something that you
yeah,
personally had a go at doing? Have you had a go at developing a Bitcoin client?
I mean, it would be interesting, but I think I would stick with what it's already out there. And this is only to get like the extra. I really know about Bitcoins and blockchains, but yes, I really encourage those who are interested to look for these type of online resources nowadays. You will find a lot of resources very digested. So it's like you're not telling anything specific. Let's say you start with the general context, then you go into the details. So I had some drawings here in the board.
Oh, yes.
Like how do transactions talk to each other, or how they are referenced, the details, the technical details of this. And the more you start to understand, the more you get to see why Bitcoin was actually such a huge thing when it came out. Because it is really, really interesting, and it's quite a smart solution to the problem that we were describing.
Yeah, cool. And I'm getting a question in here to do with why is this buzzing around Singapore so much? Like I saw was it IBM or Microsoft really developing something in Singapore, and why does it feel Asian centric, this technology? It's been kind of slow. We were too slow in Europe and America and Australia from where I'm from, but it seems to jump out of Asia.
Oh, okay. So I have to give a lot of credit to Singapore, because it's a country that puts information technologies on top of the priority lists, which I personally find very good. So they push the development and research in these areas to see if you can actually come up with usable solutions that will improve the country. So yes, it might happen that we reach sort of a point where, okay, we cannot really see any more of bitcoins, but that's I mean, it's really hard to say at the moment if that's going to happen. It could happen, but the more you research, the better you start to understand the problem, and the better you can actually try to see where to expand. So as I was saying, Bitcoin could be very, the blockchain technology could be very useful to remove trust from systems that you don't want to have trust. But you're stuck with all these other challenges of privacy and things like that, and that's where research could go in. If you solve these problems, then I don't see, for example, no reason to widespread this technology. As I was mentioning before, one reason why banking systems are not using this is because, well, for several reasons, mainly of efficiency and all that. But if you solve these problems, if you put resources and people into trying to solve these problems, maybe in the future it's actually more profitable for the banking system to use Bitcoin. Maybe. So if it's economically viable and profitable, it will happen. So this is how I like to see it. And IT is usually, I mean, we have seen the boom in these years where the big technologies nowadays are like these technology enterprises. So yeah.
Cool. And so I'll just open it up now if has any questions come through. Okay, so I just asked one question myself. This idea of efficiency to me is fascinating because when I did brief research into the technology, it seemed one of the highlights was the ability that the transaction missed the middleman and happened almost very quickly, because it's just the digital transfer of the information. And then you start to understand the complexity of the problem when 1 second is too slow for a transaction, when you're talking about huge banking systems wanting to transfer many different transactions at the same time. Yet for me this is confronting to think that it's also these problems of scale. So once you're working on a small scale, you have different problems, and probably there are many stacks in terms of the scales, in terms of what different problems you are going to face. And I think as a designer, my entry would be obviously into the smaller end of Bitcoin, and then the efficiency wouldn't be a problem.
Mm-hmm.
But as a computer scientist, and your interest in the field, in which scales of the problem do you find yourself mostly focused in?
So let me think for a second. Okay, so as I was mentioning on the different application scenarios, it should come with the requirements of your application. So if you're saying, I really need something very efficient, so if you're streaming or something like that, this won't work. So it has to be, it has to sort of match what you want to do. If your priorities are, as we were saying, transparency and all that, you could use this technology. I personally am focusing on security. So if there is an application scenario where you really could provide these security properties, let's say transparency and anonymity and all these type of things, you could perfectly use this, and you will have to work on the very details of here's how do you prove that the system satisfies what you wanted. So this transparency and this traceability or whatever, and how would you attack the system? So this is the research that I would be interested in.
Yeah.
If I try to be the bad guy, what could I do to the system? Can I corrupt it? How much would I need to control in order to corrupt it? How can I bypass the security mechanisms of the system to try to get what I want? So this is sort of like the area that I'm interested in, because from the functionality point of view, this works for these scenarios where I was telling. But when you put security, which is sort of orthogonal to functionality, there is a different scenario. So it's like, okay, do my security requirements, are my security requirements satisfied by the current implementation? And if not, how do I actually incorporate them? So this is what I'm interested in.
All right, cool. Yeah, that's and do you have anything you would like to close with in terms of where your work is going in the future?
Okay, so although I find the topic fascinating, I am now currently not working on blockchain. I might use it in the future because when you're verifying, let's say, big systems, trying to verify them all together is very, very complicated. So you want to, let's say, split it into several modules and verify the different modules independently. This comes with a catch, and it's like you're verifying these modules under certain conditions. So let's say this module says I provide the guarantee that I will behave like this if this context is provided. So you can write this sort of contracts in this. So say, okay, this module says this, under these circumstances, this happens. This other module says this happens. And then you create a collection of contracts that you could use together. Let's say, okay, this person or this module made this commitment, this module made this commitment, and this module made this commitment based on this commitment. And you can see sort of, okay, if this goes after this and this goes after this, you can sort of see like similar to things to transactions. And maybe if you start verification, I have a very, very funny scenario where you want to formally verify something, a public transportation like a train, where you need to provide certificates that this thing was certified, etc. It takes a lot of money, it takes a lot of time, and this is why the systems are not updated so frequently.
Yep.
But if you can sort of create the technology using blockchain to certify, okay, this train was certified here, I can provide also a new certification that builds on top of this other certification. And you can show that if the changes that you did to the software of the train sort of match the difference between these two certificates, you could sort of be safe. This is one of these possible applications of the technology, but then again, it depends on what you want to achieve. What is your ultimate goal? Currently, I don't personally believe that the security of the systems is so mature, of these systems that have this cyber and this physical part. So it might be a long way before we see applications in this domain. But in other domains, as you were mentioning, we might definitely see something come by. I don't know, it's a matter of who comes up with the great idea first.
Okay, we are running out of time, but for me that's a very interesting point to finish on, because we're talking about how blockchains can enter into the physical world, and as a designer, this is where it gets interesting for me as a design challenge. So you've left me with a lot to think about.
Sure.
Yeah, so thank you, Eric Rothstein, and yeah, it was a pleasure to have you, and yeah, thank you for coming along.
Thank you for the invitation. It was very nice talking to you, and yeah,
Yeah, cool.
hopefully you like the talk.